a similar line topic here, so again it's Radon research, and it's going to be a quick, very quick review. So I'm just run to an example, and I'm conscious of the fact that you're eager to get lunch as well. But a quick review of radon research that's been happening in Ireland, and some current projects, some future projects, and I'll probably skip a lot of work that people in the room have done before, like David and colleagues, so apologies for this out. So just a quick, I'll go through the intro very fast. I presume most of you know the dangers of radon. It's an alpha emitter, it's radioactive, you breathe it in, and it causes, in Ireland, typically 150 to about 250 are the estimates, lung cancer deaths, about 10 to 15% of lung cancer deaths. So the figure here, which is pretty significant, is the amount of radiation you're exposed to as an Irish person. Medical procedures and different things are in around 10%. Radon is up there at 56%. That's average across the whole country. Now, as we've heard already from Eamon, there's high radon areas and low radon areas, so it varies. We saw the map already. So it fluctuates across the country. Where does it come from? This is radon here. It's Uranium-222. It's got a 3.8 day half-life, so it decays quite quickly. It's an alpha emitter. Alpha emitters are quite good if they're outside the body. When you're breathing in this gas in your house, it deposits the energy in your lungs, so it can cause, as we said, lung cancer. And here are some of the daughter products. So this is just some of the basic nuclear physics. You can see polonium and things here. And these cause DNA damage and induce cancer. Where does it come from? If you look up here, it's Uranium-238. So that's the origin. So it's basically coming from geology. And we can talk about why houses fluctuate so much and things in a second. Okay, so design of the house is very important. So a lot of you are talking about energy retrofit and things. So in terms of radon, atmospheric conditions will have a big bearing. Atmospheric pressure, wind, temperature inside and outside. House design has a bearing as well, so that's what you're talking about now, and also the geology. So what you find is you have estates with similar house types, but you can get large fluctuations in radon levels. We've seen that, I'll show you some data in a second. In terms of, Eamon just mentioned the Irish figure for the average roughly across the country. This figure has dropped down recently, but the use quote about 89 becquerels per cubic metre for the Irish average level across the country, indoor level. Outdoor is much lower, 4 to kind of 6 becquerels per cubic metre. And globally, you're talking about in around 39. So if you look at the UK figures here, UK is quite low. You can see here in around 20, 30 becquerels per cubic metre. So reasonably high in Ireland and very high in some areas. So just where you are now in Galway, these are quite old figures now. You can check the EPA, I should say now, EPA website for updated figures. But there's over 5,000 measurements in Galway. It ranks as the third highest county in terms of radon levels, up around 1 in 5 houses above the reference level. Sligo and Waterford are other high counties. And in terms of what kind of measurements you get, in around 3,400 being some of the higher measurements in Galway. So it's been recent measurements, 2,000, 3,000 becquerels per cubic metre. So again, if you think of the average across the country is around 90 or slightly less than that, you get values in the thousands all the way up to, you're probably familiar with the one in Castle Island, which is 49,000 becquerels per cubic metre. So there's a large variation, and that might explain some of the reason why, when you look at the energy retrofit as well, that you might get fluctuations in houses as well. It might explain some things. When you look at the means, it doesn't give you the whole picture. It's kind of, the stats hide the actual picture. One of the problems as well is when you tell somebody it's 3,400 becquerels per cubic metre, they say, thanks very much. They don't do anything a lot of the time. But sometimes what the EPA have been doing recently is equating it to number of chest x-rays per day, which I think makes people a bit more aware of the dose you're getting. So if you're getting 11 chest x-rays every day, you say that to a family, you say your kids are getting 11 chest x-rays every day in that house, equivalent dose. I think that has a bit more of an impact than saying 3,000 400 decays per second per meter cubed. They don't really care about that a lot of the time. Yeah. Okay, so some research. I think, I could be wrong on this, but a lot of research started in Ireland probably around the 1970s in the School of Physics. Jimmy McLaughlin at UCD started. Could be correct on that. The RPI have data going back. This is just one study they did in the 90s, early 90s, looking at houses. And here we looked at this, we followed up on this 20 years later, but this is Salt Hill, 160 houses in this study, average level 212, which is in around the reference level. So you're talking about 30% of houses in this study are above the reference level, so roughly 1 in 3 houses almost. And the highest level again, 2,000, 3,000, and we're still finding houses in Galway around that level. So we decided we'd take a look at this and do some research on it, and we'll do some measurements. So how you measure it? Very quickly, the kind of gold standard is you get a CR plate, you leave it, you can leave it for a year, but the recommendation now is about 3 months. One thing we're interested in is, could you leave it for a month? And Stephanie and colleagues in the EPA have looked at this before, and we want to look at this, continue to look at this to see if you left it there for a month, how would it compare to a 3-month measurement? The idea of leaving it for a year is to correct for seasonal variation, because obviously the atmospheric conditions in the summer should be, not this summer, but should be different to the winter, but sometimes not the case in Galway anyhow. We also want to do some research on digital monitoring, so could we use some new detectors that are coming out, and would these be effective as maybe just a screening tool for houses? So you could do a quick measurement, say for example you could do a 1-week measurement, and how accurate would that be? The CR plates, again this is work carried out by the EPA, they published this work in 2008. These measurements, the gold standard, the quoted uncertainty are in around plus or minus 27%. Sometimes they're more accurate, but in this paper they quoted 27% as the accuracy in this. So how accurate are these digital monitors? Some of the manufacturers will say 5% accuracy after a week and things, but I want to kind of check that. And the seasonal correction factors, again the EPA have looked at this. Up until 2009 they were using UK correction factors, but then they started to use Irish ones, and there's regional correction factors as well. Okay, so let's skip this. Basically this is just to say that there are quite a few houses that haven't been tested, and it's going to take a few hundred years to test them. So at current rates of testing is around I think 4,000 or 5,000 per year. So this 3-month test has stopped basically implementation of a lot of testing programs and things, because it's quite a long time to wait. If you wanted to bring it into this, if you were selling it at home and you wanted to wait 3 months to get a radon test, I think this would be this is an obstacle or barrier. Whereas if you do it within a month or 2 weeks, you would I think a lot more people would test their homes. So just to mention some studies are ongoing. Again, in the EPA, Stephanie Long and David Pollard and David Fenton have been doing a lot of work in this area in recent years, in collaboration with people in NUIG and School of Physics in Trinity. As I said, we wanted to compare these track CR plates with different types of digital monitors, and some of these detectors, I'll show you in a second, range in cost from relatively low cost, €200 for the Canary monitor, all the way up to €10,000 plus VAT for some of these monitors. So if you can get a digital monitor, give you an accurate reading, and it costs in around €200, I think uptake would be quite good. CR plate is going to cost you probably, these measurements will cost you probably €50 to €80. So we also wanted to look at the school survey. So there was a very large school survey carried out by the EPA or the RPII at the time, starting around 1998. And there's a lot of data there, but not much has been done with it at the moment. So, and a lot of these schools have been retrofitted, and there's some interesting results we've just got in the last week. Looking at this, we hope to publish work on this school data, which I'll just mention briefly in a second. So we're finding that schools that were actually measured in 1998 and remediated, and levels dropped off. Some of the levels are actually creeping back up again, and some schools, the levels are actually exceeding the levels they were originally. So this is kind of a concern, because suppose some people and some schools and board of managements assumed their house or their school is remediated, rooms are remediated, and it's job done, and don't worry about it. So that's what we're finding. And they're not checking are the fans working, or people switch off the fans. And now we're finding actual radon levels in schools are actually getting quite high in some schools again. Some of them are fine, just like homes. It's the same idea in homes. We find some homes are fine, but some of them creep back up, which I'll show you in a second. So I'll show you some of this data, and we're going to hopefully do some work in the future with the European Radon Association and look at some international studies as well and do some comparisons. Okay, so very, very quickly, some of the digital monitors. I'll just mention here the CR track detectors. This is a Canary, it's called a Canary monitor, Sun Nuclear, a RAD7, and we have an Atlas. We've got the Orstone and RAD detectors. So some of this work was carried out up in the radon chamber, really to control atmospheric conditions. We've done some work in houses, but you have to monitor different things and you've less control over atmospheric conditions. So this is kind of our control testing where we do at the radon chamber in Dublin. And we have calibrated detectors, an Atlas detector, monitoring the radon levels and benchmark against that. So here you'll see just some of the data. At the moment, our most recent data has 8 digital monitors, and we're looking at how good are these monitors relative to the Atlas, which is the calibrated detector that we are using, which is the blue line here. And as I said, we've 8 lines now. He only shows 3 here, but we've got 8 detectors, and this paper should be coming out soon. The paper is ready. We were just discussing it last week with the EPA, Stephanie and colleagues. It's an intercomparison of radon detectors for 1 to 4 week measurements and potential applications, because we're looking at going from, as I said earlier, 1 year, 3 months, down to potentially 1 to 4 week measurements. And can you get the accuracy less than 20% or less than 10%? And some of these monitors are actually performing very well, and the cheap ones, €200, performing almost as good as the very expensive ones, within kind of 10%. So this is kind of, I think, promising work here. Okay, so let's just skip on. So very quickly, residential study. We looked at Salt Hill. We offered free radon monitoring to 176 houses, and of course only 60 wanted it free. And we placed detectors in there. This study, really what we're looking at this time is 1 month versus 3 months. That was our main goal at the start, but then we picked up some interesting things along the way, which is renovations and retrofits in the houses. So very quickly, and again this goes back to means and things, which we just saw in Eamon's talk. The mean 1 month was 217 becquerels per cubic meter across those 60 houses. And the mean on the 3 month was 222. So if you look at the means, you'd say 1 month, that's pretty good to be out by just a small amount within the uncertainty of the CR rates, which is 27%. This is CR measurements, by the way. But then if you look at, and also if you look back to the work that EPA did back 20 years ago, and the interesting thing was this study I showed you earlier was 160 homes, and the mean value back then was 213. Relative to our study, it was 212 when we included all the values. So that's kind of human side to it. There's a lot of awareness in Galway about radon, and a lot of awareness in Salt Hill, particularly because of campaigns the EPA have done, talks that like Stephanie have done in the past in Galway. But yet, after 20 years of these campaigns, after measuring these 60 homes and these 160 homes over a 20-year period, we didn't see any change in the average reading level. Which is kind of interesting. I expected at the start that this would have dropped off, just really because of awareness. And we found there was a lot of awareness, but often we found hot levels very high, but people often say, I've lived here for 20 years, why bother remediating? So that's common across our studies as well. Okay. So we did find, again, these are means. We do find houses that have very large differences. So you see here, this one particular one, where you can find huge variations. So maybe just look at the graph and maybe easier to look at. So these are 55 of those houses, and you can see the 1 month is in the yellow, and the blue is the 3 month, and here's the level all the way up to, as I said, almost 2,000 becquerels in this one. So you can see some of them do have large differences, but the mean hides that. See, the mean is quite close. Okay, if you plot it like here, 1 month versus 3 months, it looks pretty good for the 1 month measurements, pretty accurate. And I'll talk about the detection rate in a second. And just to mention 4 particular homes in this study, this is kind of interesting. All these 4 homes were remediated. This one went from 2,000 becquerels per cubic meter to 82. So that's what you kind of expect. It's gone below the average with a fan-assisted sump. This one went from 1,200 to 360. And this one went from, dunno, to 389 with the remediation. And this one went from 350 to 150. And this is the problem, is it's inconsistent. This is one of the problems that's been highlighted before. You got one remediation working very well here. You get remediation that works at 90% efficiency. And you find here, this house remediated went from 1,200 to 360. It's well above the reference level. So this is an issue as well that's been highlighted before. Okay, so just to conclude, the 1 week tests obviously are pretty unreliable at the moment. The 1 month test, if you look at the reference level, we're detecting 95.6% detection rate for 1 month screening to check if a home is above the 200 becquerels per cubic meter reference level. So it works pretty well to detect if a home is higher or low in our sample, which is about 60 homes, and Stephanie has looked at other homes as well. There's quite a big human behaviour element and awareness, and this has been found in other international studies as well. If you in our 60 homes, 43% were above the reference level. If you go back 20 years, 31% of those 160 homes are above the reference level. So even after all the campaigns and all the awareness, we're finding a sample size of in around 200 homes, the levels are not changing that much, even though a lot of houses have been remediated. One thing I think should be highlighted as well is a lot of focus is on high radon areas, but often we forget the rest of the country, and we're talking about dose. And if it was medical procedures, we'd look at doses across all procedures, compare CT scans to X-rays and things. But with radon, we tend to focus on high radon areas. I think there should be more focus on low radon, so should we try and just reduce radon across the country, really, because it is quite high relative to other countries. There's some interesting studies coming out, as we saw already from Eamon, Swiss, Austrian studies, and also there's a Czech study that's published recently on schools. And again, we're going to publish our school data as well, and it'll actually show you some interesting trends. The means hide a lot of the information. If you look at the means, you're not seeing huge changes with retrofitting, things like that. But if you look at particular schools, you will find schools, for example, with 8 sumps, and they assume they're remediated and the levels are creeping way back up to where they were, above where they were 15 years ago. Okay, Jimmy's getting edgy, so I must be close to the end. Just to mention some future projects, again, David mentioned this, there was a call from the EPA last month, the call closed, and there's several 4 radon projects here, so some people in the room are involved with proposals for this. We've got about 3 proposals from NUI Galway, so hopefully we'll have some funding in this area. David mentioned some of it's related to aggregates, some of it's relating to passive sumps, some of it is energy retrofitting is in here, 36, and also the level of the exhaust is in here as well. So this all comes from the National Radius Control Strategy. Thanks, I stole a lot of slides from people from the EPA, School of Physics in Trinity, and Alpha Radon in Perry did some of the analysis as well. So.